All right, this is, we're going to be talking about section 5.7 today, and our main focus is going to be on slope. And this relates a lot to graphing and what we've been talking about, as well as ratios, fractions, and moving between numbers. And we're going to kind of combine all the things that we've been learning about so far. Let's start off with a definition of what slope is. Slope is the steepness of a line. We're going to start looking at lines, and lines can have all sorts of different kinds of steepness. They can be like this, be like this, they can be like this, all kinds of different slopes. And we're going to find out how to exactly find that out. Now, when we're talking about slope, the typical formula or the way that we write this out looks like this. We say it's rise over run. So that's, we'll come back to that in a minute. Or we see it like this. We see it written, we say this as the change in y over the change in x. This little triangle is actually a letter. It's a letter in ancient Greek, and it is called delta. And delta, when we write it in math or physics or anything like that, it means change. So whenever we see this, this really means the change in y over the change in x. And we could say the change in y is really how much something rose or got higher, and the run could be how much something changed along the x-axis. So it does kind of fit and make sense. Let's take a look at a quick example so that we can see how this is going to work. We have a family going ziplining. Let me get some other colors. And if you've never seen a zip line, zip lines usually start from something high. Let's make like there's a little cliff right here. And we're going to make a pole come up. And then on the ground, usually like goes to another little pole like this. We'll anchor it to the ground. We'll anchor this one to our little mountain. And between those 2 points, we tie a rope. And it's not really a rope. It's actually more of a cable. It's usually a little straighter than that, but it wasn't too bad. And you kind of hop on. I guess this person is giant. And you kind of slide down this direction. And the slope of this line is very important because if you don't have an adequate slope, you are either going to go too fast and crash and die at the end, which would be bad, or you get kind of stuck here if it's too flat. Because a zip line that had a line like this would be very boring because you would just get stuck on this flat line. There would be no slope at all, right? So it'd be rough. But let's look at some information about this. If I'm going to write my information, the distance between the bottom and the top is 20 meters. And the distance from the start to the finish is 200 meters. The question is, what is the slope? Well, fortunately, we can use this handy-dandy little rise over run exactly that we were using. So first, we're just going to put the change in y over the change in x, or the rise over run. Okay, so from the start, right here, to the end, how much did it rise? How much did it go up? Well, it didn't go up at all. In fact, it went down. So in this case, we're going to say it went down 20 meters. And if I'm showing a down or an opposite compared to normal, I'm going to use a negative to show that. Over the change in x. Now, if this was my origin and I went this way, now this time it's positive. I'm going this way. And I went 200 meters. Once I've got this, I'm going to do the same thing that we've been doing before with these unit rates. And I'm going to simplify it down to so that one of them is a 1. And that's going to make it easy for me to see the change. Okay? Now, the answer that we've got is like this. we're going to simplify. I'm going to cross off those zeros because I can always do that if I'm dividing. Which gives me 2 over 20, which is going to be negative 1 over 10. And that's going to tell me that the line of my slope is negative. It's going down. And it's not that steep. It's more like this, instead of a very, very steep line, which is probably good for a zip line. Let's take a look at a couple of examples and how we're going to continue finding slope. First, let's take a look at 4 little examples that we're gonna just draw out, and this part's easy. We're gonna make 4 little miniature graphs. 1, 2, 3, 4. Each of them is going to have a different line on it. This one has a line like this. This one has a line like this. This one has a line like this. And this one has a line like this. These are the main 4 different kinds of slope that we're going to be dealing with. In this case, we say that the line slants up we're going to say that the slope is positive. For this one, our line slants down. We're going to say that it's negative, just like our zip line that we made earlier. For this one here, our slope, our line, oops, wrong color. Line is horizontal. And in this case, we say that our slope is 0. It's because it doesn't rise at all. And in this one, we say, well, it's going to be a little crowded for me, our line is vertical. And we would say that our slope is undefined. The reason is because it doesn't move x. So my slope would be, or my rise would be infinity divided by 0. And in this case, both of these don't make any sense. So our answer is undefined. So this line does not have a slope. So the opposite of the 0 in this case is infinity over 0. Now, all of the graphs that you're going to be doing on your homework, you're going to need to identify if it's positive, negative, 0, or undefined before you do the work. We're going to draw one example, and then I'm going to send you on your way. I need my next page. You might want to use a piece of graph paper for this. Now, this does not have to be perfect, but I'm just going to do the best that I can. Okay, let's make a graph. And let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm just going to go 5, 5, negative 5, negative 5. And I can count back from anything else that I want. My first point that I'm going to do is I'm going to go negative 4, comma 4. So it's going to be right here. The next one that I've got here is 2, 1, 2, comma, negative 4. Now, if I need to find the slope of this, and I'm going to have a line that runs between them, Let's see, I don't have a ruler over here. Do the best that I can to make my line. Not too bad. And the question is, what is my rise over run? Well, if I start here and I go to here, I'm going to be going down. And I go from 4, 1, 2, 3, 4. Oops, I put that point in the wrong spot. It should actually be here instead of here. Sorry about that. Well, we'll use this -4, 4. Oh, man, my line is getting messy now. That's okay. Rise. So we're up 4. 1, 2, 3, 4. And then we went down 2. So it went the total distance here, if I were to draw a big dotted line, is I went down 6. So my rise would be -6. How far did I go this way? Okay, so I started at -4 and I ended up at 2. So again, I would be at 6. Let me write this again. I would be at -6 over 6. So in this case, this slope would be, let me check and make sure if I did something wrong, because I think that I did. My rise would be -4. I did. This is not a 6. If I was at -4 here, I would go, 1, 2. Oh, I know what I did. My -4 here, I'm at 4. 1, 2, 3, 4. I would go down 4, and then I went down another 4. So my rise, see, make mistakes too, is actually going to be -8, and my run was correct. I went across 6. So in this case, what I want to do is I can turn this into a regular integer, and I can do that just simply by dividing. So if I wanted to, I can use my calculator, or I can use long division. It's up to you. Let me grab my calculator app. So in this case, let's do -8 divided by 6, which is going to give me -1.33 repeating. And in this case, this is going to be my slope. I could also write it as a simplified version of -8/6, which would be -4/3. That would be okay too. This line is definitely going negative. The slope is negative. And I can confirm that by the negativeness of my slope answer. This is what I'd be looking for the answer to all of the graphs that you guys are going to be doing. Hopefully you won't make as many mistakes as I did when you're graphing it. And in fact, the graphs will actually come with it, so it'll be easier. All right, hopefully that makes sense, and good luck.